All right, let's take a deep dive today. We're going microscopic,
Yeah.
it's like really small, into the world of hookworms.
Hookworms. Fascinating, aren't they?
They are, especially, Necator americanus. That's the one we're focusing on today.
Yeah, they really are something else.
Right. And you want to know about how they actually infect humans, even with, all of our modern medicine and stuff?
Yeah, I mean, it really is remarkable.
It is.
These creatures, they have this whole complex life cycle, and they're navigating a human body that's actively, trying to get rid of them.
Yeah, that's what makes them so interesting, right? It's kind of like a microscopic heist movie.
Oh, yeah, I like that. I like that. A heist movie.
Our source material today, it's this research article. It's called The Physicochemical Fingerprint of Necator americanus. And it really kind of helps us, trace the hookworm's moves as it, does this invasion.
Oh, wow.
Now, you've probably heard that hookworm infections, they affect tons of people all over the world, hundreds of millions.
Yeah, absolutely.
But here's the thing. The thing that makes it even more interesting is that even when we have treatments that can actually, get rid of the adult worms,
Right.
people in areas where hookworms are really common, well, they end up getting reinfected super quickly.
And that's the puzzle, right? That's what we want to find out. How are they getting back in? How's that happening so easily?
Yeah, it's a real mystery.
It is. And the researchers who did this study, well, they think the answer might be in this really clever trick that the hookworm uses during the initial skin invasion.
So the mystery is, how they're pulling off the repeat performance, right?
Exactly.
Okay, so to unpack that, the researchers, they focus their investigation on the hookworm's outer layer. We're talking the surface that actually touches our skin when those parasites burrow in.
Yeah, and it's kind of like the hookworm has a two-part disguise,
Yeah.
right? So there's the cuticle, which is the permanent outer layer, but then there's this sheath, which is temporary, it's protective, and the hookworm actually sheds it during the invasion process.
Wait, so imagine you could make a hookworm shed its skin whenever you wanted,
Yeah.
on demand.
Uh-huh.
That's basically what these scientists figured out.
Yeah.
They figured out how to do, they triggered controlled shedding of the sheath in the lab.
Yeah.
So they could actually analyze the sheath and the cuticle totally separately.
That's amazing.
Right.
So it's they're examining this discarded disguise to figure out how the trick works.
Exactly.
And to do all of this, they use some pretty incredible technology, really high-tech stuff.
Yeah, what kind of stuff?
Well, things like atomic force microscopy, which lets them see the surface in crazy detail, amazing detail. And then there's this other thing called time-of-flight secondary ion mass spectrometry.
Oh, that's a mouthful.
It is, but it basically helps them figure out what molecules are actually on the surface.
So they're making a molecular map of the hookworm's exterior,
Exactly.
almost like a fingerprint.
Uh-huh. Like a fingerprint. I like that.
Okay, so what did they find when they compared these fingerprints of the cuticle and the sheath? What was the difference?
Okay, so the cuticle, that permanent outer layer, it turned out to be really, really smooth.
Okay, smooth.
And that's not by accident. It's because it's full of this molecule. It's called phosphatidylglycerol. And, well, it acts as a lubricant.
Ah, so the parasite is greasing the skids for its trip through the skin.
Exactly.
That's clever.
Yeah, but that's only half of it, right?
Right.
What about that discarded sheath? It can't just be there doing nothing, right?
Right. There's got to be something going on there.
There is. That's where things get even more interesting, I think. It turns out that the sheath is coated in molecules that look a lot like something called heparan sulphate,
Okay, heparan sulphate.
which is this type of sugar molecule that's actually, naturally found in our bodies.
Wait a second. Are you saying the hookworm is basically wearing a disguise that looks like us?
Exactly.
Ooh.
And not just any part of us. Heparan sulfates, they play this really important role in how our immune system actually communicates. So imagine our immune cells, right? And they have this set of secret passwords that help them recognize invaders.
Okay.
Well, it seems like the hookworm is covering itself in fake passwords.
Wow. That is sneaky.
It is sneaky.
So what happens when the hookworm actually sheds the sheath in our skin? Is it like throwing a smoke bomb to create a distraction?
Yeah, that's a great way to put it, like a smoke bomb. So the sheath embedded in the skin, it basically floods the area with these fake passwords, these heparan sulfate molecules. And it's like this diversion, it distracts the immune system so it doesn't recognize the real threat, which is, the hookworm itself. And the hookworm, meanwhile, is, busily burrowing in, all nice and slippery with its lubricated cuticle.
Okay, so we've got this two-part strategy. First, the deceptive sheath to create confusion, and then the slippery cuticle for a smooth entrance. No wonder reinfection is such a problem if the hookworm is this good at getting past our defenses. But how can we be sure our body is seeing these two surfaces so differently? Like, how do we actually know that the sheath is working as a disguise?
Well, that's where those really high-tech imaging techniques come in, that the time-of-flight secondary ion mass spectrometry.
The ToF-SIMS?
Yeah, the ToF-SIMS. That one let the researchers actually see the chemical differences between the sheath and the cuticle. And what they saw was a really big contrast. It's like the sheath is this bright, flashing neon sign, and the hookworm itself is, like a stealth bomber, just slipping by.
So the hookworm is using the sheath to, like, misdirect our immune system.
Exactly.
This is starting to sound like a pretty impressive strategy for such a tiny parasite.
Oh, it is. It really is. And remember, this is only the first step in the hookworm's whole invasion process.
Right.
Who knows what other tricks it might have up its sleeve, or I guess under its sheath.
I am definitely hooked on this deep dive.
Mhm.
We're really starting to see like how complex this whole relationship between the parasite and host can be. But I think we've covered a lot today. Let's take a moment and let all this sink in for a bit, okay? And then when we come back, we can explore what all of this means for, like, the future of hookworm treatment and prevention,
That sounds good.
Okay, so we're back and ready to keep going deeper into this whole hookworm thing. Before, we were trying to figure out how they reinfect people so easily.
Uh-huh.
And we learned about the deceptive sheaths and the slippery cuticles.
Right.
But I feel like there's still so much more to figure out. Like, what else did these researchers find out about, the hookworm's sneaky invasion tactics?
Well, it's not just about, like, what the sheath is made of, It's also about, like, how the hookworm actually behaves during that moment when it sheds the sheath.
Right.
So remember, the sheath is stuck to the skin's surface, right? While the hookworm inside is, like, moving around, trying to break free.
So it's not just like a passive decoy.
Right.
It's like an active part of the plan.
Yeah. Yeah, exactly. So, like, what happens when the hookworm's moving around inside the sheath?
Yeah, what does happen?
Well, all that movement, it actually makes the sheath, like, stretch and expand, so its surface area gets even bigger.
Hold on. So it's like as the hookworm is trying to break free,
Yeah.
it's actually making the sheath, like, bigger.
Exactly. Imagine a balloon,
Yeah.
inflating.
Oh, okay.
That's kind of what's happening to the sheath.
So it's creating a, like, even bigger smoke screen.
Exactly. By stretching out the heparan sulphate-coated sheath, it's basically doing everything it can to distract the immune system.
Wow. And then when it finally, breaks free,
Yeah,
it just leaves that sheath behind in the skin.
it does. Yeah, so you can imagine, like, this huge concentration of those deceptive signals
Right.
amplifying the distraction
Mhm.
and giving the hookworm, now exposed and all slippery, a chance to, well, get away.
This is really amazing. Like, just by watching these tiny creatures, we can learn so much.
I know, it's incredible.
But okay, let's zoom out for a second. Think bigger picture.
Sure.
How does this change how we think about these kinds of infections, like parasitic infections in general?
Well, it shows how important it is to look at, more than just the parasite itself.
Okay.
We have to think about how it interacts with the host's immune system, and not just in a general way, like at the molecular level. It's a good reminder that parasites have evolved all of these, like, really complex ways to manipulate their hosts, and we have to understand those strategies if we actually want to, treat them effectively.
So it's not just about trying to kill the parasite. We have to, like, outsmart it.
Yeah.
We have to find ways to stop it from, like, deceiving our immune system.
Exactly. So imagine if we could make a drug, right, that targeted the hookworm's ability to make or even shed those heparan sulphate-coated sheaths.
That would be huge. It would be like taking away its invisibility cloak.
Yeah, exactly. Or we could develop a vaccine, something that trains the immune system to recognize and target those molecules on the sheath, like teaching the immune system to see through the disguise.
This is starting to sound like sci-fi, but it's real. Like, we're actually starting to understand all of this.
Yeah, it really is amazing.
And it's not just about hookworms.
Right. Hookworms are just one example. There are so many other parasites out there, and they all have their own ways of surviving. This study, it shows us how we can, like, use all these new technologies to look at other parasitic infections too.
So It feels like we're like entering this whole new world of understanding when it comes to parasites.
It does feel that way.
But before we, wrap up, I have another question.
Okay.
You said that heparan sulfate is naturally in our bodies,
Yeah.
right? So wouldn't our immune systems be used to it already? Like, why would it work as a decoy?
That's a good question. It's all about context, really. You see, heparan sulfate, it does a lot of different things in our bodies, and what it actually does depends on, where it is, what other molecules are around, and like the overall environment.
Okay.
What the hookworm seems to be doing is like hijacking that system.
Yeah.
Presenting heparan sulfate in a way that confuses the immune system.
So it's not just that the heparan sulfate is there.
Right.
It's how the hookworm is using it.
Exactly. Like it's the difference between a normal sentence and like a secret code.
Oh, okay. I see.
They use the same letters, but they mean different things.
Right. So the hookworm is using the versatility of heparan sulfate, basically,
Yeah.
to create this diversion. And our immune system just hasn't caught on yet.
Exactly.
This is all so interesting, but also kind of creepy. It makes you realize how clever these parasites are.
Yeah, I get that. But remember, this research is good news, ultimately. The more we know about how parasites work, the better we'll be at, fighting them.
It's like learning your opponent's moves, right?
Yeah.
Knowledge is power, especially when it comes to, microscopic invaders.
Absolutely. And this research shows how important it is to keep investing in, basic science. Because discoveries like these, even though they might seem kind of niche, they can actually have a big impact on global health.
It's like sometimes the smallest discoveries can lead to the biggest changes.
Exactly.
But I think we've given our listener a lot to think about today. So why don't we pause here, let all this information sink in, and we'll be back soon to finish up our deep dive into the world of hookworms. All right, we're back. Back for the final part of our deep dive into hookworms. We've learned a lot about these guys. Their whole life cycle,
Yeah, their life cycle's pretty amazing.
and their tactics, like how they avoid our immune systems.
It really is something.
It is.
They've been doing this for so long, millions of years, just perfecting these strategies.
I know. We've been talking about them like master criminals, but maybe they're more like con artists.
Con artists, yeah.
They're not breaking down doors or anything. They're all about deception, misdirection.
They've figured out how to fool our immune systems. I mean, one of the most complex systems in our bodies.
Yeah, and they do it so smoothly.
They really do.
It's almost like they found the cheat codes to our biology or something.
Yeah. The cheat codes. I like that.
But like we've been saying, if we can understand how they do it, then maybe we can fight back.
Right. Absolutely. And, this research shows us how basic science can actually lead to real solutions.
Okay.
By figuring out how hookworms work, all the little details, we can actually start making better treatments.
It's funny. We started out talking about how sneaky they are, but now I'm kind of impressed.
Yeah, me too.
They've developed all these complex strategies to survive. And, they're microscopic.
Yeah, it really is pretty amazing.
So where do you think this research might lead in the future? What could we actually do with this information?
Well, there are a lot of possibilities. Imagine if we could use the hookworm's ability to, change the immune system to our advantage.
What do you mean?
Well, maybe we could develop, therapies that could help with, autoimmune diseases, where the immune system attacks the body,
Wow. So we could take something the parasite uses
Yeah.
and turn it into, medicine.
Exactly.
That's really amazing.
It is. And it shows how important it is to, keep an open mind. Sometimes the most unexpected discoveries are the ones that lead to the biggest breakthroughs.
Yeah, we're always learning new things about nature.
Uh-huh.
And with every new discovery, we get more and more possibilities.
That's true.
I do have one more question, though.
Okay.
If we start, messing with the hookworm's ability to change the immune system, could there be, problems?
That's a good question. And it's something scientists are definitely looking into. It's important to remember that anything we do, even if it seems like a good thing, could have unintended consequences.
Yeah, we're playing with a delicate balance.
Right.
We want to use the hookworm's secrets, to help us.
Yeah.
But we have to be careful.
Exactly. Nature is complicated. We have to be really careful and respectful, of the whole system.
Okay.
But I'm optimistic, though.
Really?
Yeah. With more research and being responsible with, what we discover, I think we can use these discoveries to make a real difference. for people's health.
Well, this deep dive has been really eye-opening. We've gone from like the tiny world of hookworms to,
Yeah.
the whole big world of science. And we've learned a lot, asked a lot of questions. And I think I have like a new appreciation for nature.
It's been great to explore all of this with you, and I hope our listener has enjoyed learning about hookworms with us too.
I hope so too. And, there's always more to discover, more to learn about. So keep exploring, keep asking questions, and, be curious.